As we all know, the hardest part of using u-sub for integral is that what should we choose to be the u, right? Therefore, in this video, I'm going to show you guys 3 examples on how to use the u-substitution to do an integral. And then on each example, I'm going to show you guys 2 very similar integrals, because this way I can point out the little details that we have to focus on much better. And hopefully after this video, we can understand and like the u-substitution much more. Anyways, let's look at this one. The integral of secant of 2x times tangent of 2x dx. And then we also have the integral of secant square x times tangent square x dx. Let's focus on this first though. So this is the first tip of selecting the u. Ask yourself, what's an inside function? Right here we have secant of 2x times tangent of 2x, right? And the good thing is that the 2x and the 2x are the same. So that's a good choice for the u because it's an inside function, right? So I'm going to write down the steps. First, write down the selection of the u. I'm selecting that as 2x. And once you have the u, differentiate both sides. On the left hand side, we get du. And on the right hand side, the derivative of 2x is 2 dx. And then the next step is we are going to isolate the dx. I will highly recommend you guys to isolate the dx because sometimes you may have to divide, you may have to multiply. Well, if you always isolate dx, it's more clear and it's consistent. Anyways, in this case, we have to divide by 2 on both sides. So we can say dx is equal to du over 2. And with all this, we can take this integral into the u world. Let me show you. So this is going to be the integral secant of 2x. So let's write down secant. But then for the 2x, we set that to be u. So we have secant of u. And then multiply by tangent of 2x. So that's the same as saying tangent of u, right? So we can say tangent, the 2x is the u. At the end, the dx is what? Du over 2. So I can put that down. Du over 2. And you see, we don't have x anymore in this integral. So this integral is completely in the u world. That means we are on the right track. And we see that we have a 1/2 right here. And this is a constant multiple with this expression. And what we can do is we can take the 1/2 to the front of the integration. So let's write that as 1/2 integral secant u times tangent u du. And now, how can we integrate this? In another word, do we know the derivative what function will give us secant u tangent u? This is the moment that we have to know our derivative table really well. The answer to that is secant u. The derivative of secant u will give us exactly secant u tangent u. Therefore, I can finish this by saying this is 1/2 and all this is just secant u. And then we are done with the integration part, okay? And some people will tell you you can add a plus c right here, but then I would like to tell you you can just put down the plus c at the very end because we are not done yet. We have to take this expression from the u world back to the x world because we start off with x. So the last touch is that we'll say this is 1/2 secant. The u is the 2x, so let's put that right here, and we are all done. So I'll put a plus c at the very end, and I'll box the answer right here. That's it for this one. And now let's look at this integral of secant square x times tangent square x dx. First of all, do we have any inside function? Well, to figure that out, we have to look at secant square x as the following. I can look at this as parentheses with secant x inside and then raised to the second power. So secant x is one of the inside function, right? And the reason I say one of, because we can do the same thing for the tangent square x. I can look at tangent square x as tangent x and then raised to the second power. Therefore, we have 2 choices, right? Because we have 2 inside functions. The first one is secant x, and then the second one is tangent x. Which one should we choose to be the u? Well, you can just write down u is equal to secant x. And then once you write that down, differentiate that, you'll get du is equal to, what's the derivative of secant x? Secant x times tangent x dx, right? However, if we do that, unfortunately right here, we have a tangent square x, right? The derivative of secant x is only secant x tangent to the first power x. So the tangent x cannot cancel each other out completely. That means secant x is not a good choice for u. On the other hand, if we choose u to be tangent x, the derivative of tangent x is what? It's secant square x, isn't it? We happen to have exactly secant square x right here. They will cancel each other out. Now let's put down all the steps right here. Let u equals to tangent x. And let me just make a remark before I continue. Sometimes I may make a wrong choice for u. I put it down and then unfortunately it may not work. But it's okay, just go back to the question and try something else, okay? Don't be afraid to write down the steps. Alright, so I put down u is equal to tangent x. Let's go ahead, say du is equal to the derivative of tangent x is secant square x dx, and then isolate the dx, divide both sides by secant square. So we get dx equals to du over secant square x. And now we can take this integral into the u world. This is going to give us integral. We have the secant square x. Let's just put that down right here. Right? This has nothing to do with u at the moment, isn't it? But then for this part, when we multiply by tangent square x is the u. So we can say this multiplied by u square. That's the tangent square in the u world. Lastly, the dx is what we said to be du over secant square. So let's put that down right here as well. Du over secant square x. And you see, the secant square x and this secant square x cancel each other out completely. And what do we have left? This is nothing but just the integral of u square du. And can we integrate this? This is just u to a power, right? Definitely, sure. Let's add 1, so 2 plus 1 is 3, and divide by this new power, we just multiply by 1/3. So the integral for this is 1/3 u to the third power. We're done with the integration part. At the end, we just have to take this back to the x world. So this is going to be 1/3. U is tangent x. So let's put that down right here. Tangent x to the third power, huh? So let's put the third power right here. And we are all done. So at the end, put plus c. This right here is the answer for the second one. And as you can see, they may look similar, but sometimes the integral requires different step, the different choice for you. And now let's look at example number 2. For example number 2, I'm going to show you guys how to use u-sub to deal with definite integrals. And that means we have an integral with numbers like this right here. And we know the answer to a definite integral is that we are going to end up with a number, right? Unlike earlier, when we did not have these numbers right here, the answers were functions, but this time we know this is going to be a number. Likewise, this is also going to be a number. And I will show you guys how to work out everything in the u world. The first one is the integral from 0 to pi over 2 sine x over 1 plus cosine x dx. And then for the second one, we have a square right here. This is cosine square x instead of cosine to the first power x. And everything else stays the same. So you see, they look so similar, isn't it? But we'll look at this one first. And the first question is, what should we choose to be the u? It seems that we can let u is equal to sine x, or maybe cosine x, or maybe something else, right? Let me just write it down. What happens if I let u is equal to sine x? Maybe it works, maybe not. Let me just at least do it one time for you guys. I'll write down u is equal to sine x, and then we follow the usual procedure. Once you write this down, be sure you differentiate both sides. You get du, and the derivative of this is going to be cosine x. And don't forget the dx, and let's isolate the dx. Divide both sides by cosine x, we get dx is equal to du on the top over cosine x. And can we take the integral from the x world to the u world with all these ingredients? Let's take a look. So now you see this is going to be integral from something to something, but then let's focus on the function part first. On the top is sine x, but then sine is the u, right? So we have u on the top over, this has nothing to do with u, so I will write it down, 1 plus cosine x. And then the dx is du over cosine x. So I'd like to put that down right here, du over cosine x. Unfortunately, I have cosine x here. I have another cosine x here. They don't cancel each other out, isn't it? So you see, this is a wrong choice for the u. U should not be sine x, because this right here, we still have the x right here. X is not invited in the u world, and especially when they cannot cancel each other out, this is incorrect. We cannot move on. And that means we just have to go back to the equation and pick out something else to be the u. And now let's see what else can we do for the u. This time, let's let u equals to cosine x. So I would like to write that down. U is equal to cosine x. And when I do that, I know the derivative of cosine x is negative sine x. And when I divide it by negative sine x, this sine x and that sine x will cancel each other out. But then, I'm not going to just let u is equal to cosine x. Better yet, I can in fact let u equals to the whole denominator. I can say u is equal to 1 plus cosine x. Why? Because when I differentiate this, I will get du is equal to the derivative of 1 is 0. So it doesn't hurt the negative sine x. It doesn't hurt my earlier plan, right? So sometimes it may be helpful if you attach the 1 plus, just like how I'm doing right here. So it doesn't change the derivative that we talked about earlier. Du is still equal to negative sine x dx, and isolate the dx from here, we get dx is equal to du over negative sine x. And now we can take this integral into the u world completely. Let's see. We have the integral, and then on the top we have the sine x. Let's just write that down. And then let's worry about the function part first, okay? The whole denominator, 1 plus cosine x, is what we set it to be the u. So the whole denominator is the u. And then for the dx is the du over negative sine x. So let's put that down right here. Du over negative sine x. And you see, cancel, cancel, right? So that's very nice. I don't have x anymore. And now, as I talked about it earlier, I want to work on everything in the u world. What can I do? Well, I'm missing these numbers. And if you go back to here, this is 0 to pi over 2. However, those were the x values. These numbers mean to have x is equal to 0 up to x is equal to pi over 2. I cannot just take 0 and pi over 2 and put it down here, because technically they are also not invited in the u world. I have to change that correspondingly into the u values. How can we do that? Well, let's use this equation here. So you'll see when x is equal to 0, all I have to do is plugging 0 into this x, I can calculate the value for u. So let's do that real quick. Plugging 0 into here, we will get u is equal to 1 plus cosine x is 0. Right, this is the work we have to do. And you see this is going to be what? Cosine 0 is 1. 1 plus 1 is 2. So we have a 2 right here. That means the bottom number is u is equal to 2, right? And let's look at an upper number. When x is pi over 2, plug into here, we get u is equal to 1 plus cosine of pi over 2 for the x value. And let's work this out. What's cosine of pi over 2? It's 0. 0 plus 1 is just 1, right? And you see, this is a little bit strange, but it may happen. You see, this right here, u is equal to 2. This is the number corresponds to the x is equal to 0. And this number is going to be u is equal to 1, right? Sometimes it may happen after we do the translations. This number is bigger than the top number. Earlier, 0 was smaller than pi over 2, right? But this time, the bottom number here, 2 is bigger than 1. It may happen, then you just have to work out this carefully. All right, now let's integrate this. But before that, pay attention to anything from here. we do have a -1 in the denominator. 1 over -1 is -1, but it's a constant multiple. We can take that outside, so we can bring the -1 right here, and then we have the integral going from u is equal to 2 to u is equal to 1, okay? All this is in terms of u now, and we'll finish up everything in u. This is 1 over u du. And can we integrate this? Well, we have to have the -1, and the antiderivative for this that we can use is ln absolute value of u, right? 1 over u is going to give us ln absolute value of u. And then be sure we plug in the values going from 2 to 1. And be sure we plug in the number on the top right here first into this right here, and then subtract, plugging this in here. So do everything carefully. Plugging 1 into here, we will end up with -1 times ln, so I'll just write down -ln absolute value of 1. This is the first part, isn't it? And then minus, I have to plug in 2 into here. I will end up with this is -ln, so this is -ln absolute value 2 in here. So this is what we have. Okay, so let's work this out. What's 1 instead of the ln? ln 1 is 0, so this is just 0. Negative times negative is positive. So we pretty much have positive ln of absolute value of 2. But 2 is positive anyways, so the answer is just ln 2. Right? This is 0, this is positive, so altogether we have ln. You don't need the absolute value because 2 is positive already. So the answer to this is ln 2. That's it. Alright, let's look at this right here. When we have the cosine square x instead of the first power, what should we do? Can we still use the same strategy? The good thing is that we still have the sine x on the top, right? So hopefully we can somehow connect with what we did just now with this. But then can I let u equals to the whole denominator? And once again, let me write this down for you guys. Maybe it works, maybe not. If you want to let u equals to the whole denominator, I will get 1 plus cosine square x. And I have to differentiate both sides right away, right? So I get du equals to derivative of 1 is 0. But what's the derivative of cosine square x? Don't forget to bring the 2 to the front. And then the inside stays the same, which is still cosine x. And then 2 minus 1 is 1. But the inside function is cosine x. So we have to multiply by the derivative cosine x because the chain rule, right? So we have to multiply by negative sine x. And of course, you can touch the dx after that. But you see, if you let u equals to the whole denominator, du is all this, 2 times cosine x times negative sine x dx. This is not going to be as nice as this, because on the top, we only have a sine x, right? So we cannot cancel everything out that we want. Therefore, this is not the correct choice for you. So what can we do? Let's talk about the inside function again, especially when you have cosine square x, this. You can look at this as what? Cosine x and then raised to the second power, right? So as you can see, an inside function right here is just the cosine x. So I'm going to just let u equals to cosine x. And let me just draw a line in between right here for you guys. Now, this is the time to work this out correctly. I will let u equals to just the inside function cosine x. I don't have the right to put on 1 plus because the inside function is just the cosine x, right? Okay, if I have this, you see du is going to be negative sine x dx, and you see that's pretty much the same thing over there. Very nice. And then I want to isolate the dx, so dx is going to be du over this, du over negative sine x. And now I will take this integral into the u world. So let's see what we end up with. This is going to be the integral. But then I want to take off these numbers. These are the x values, right? So when x is 0, that's plugging. You get u is equal to cosine 0, and this is going to give us 1. Cosine 0 is 1. So this number right here is u is equal to 1. And when x is equal to pi over 2, plug into here, we get u is equal to cosine of pi over 2. Cosine of pi over 2 is 0. So the bottom here is 1, and then the top is u is equal to 0. And once again, the number is big on the bottom and then small on the top, but it may happen, right? Okay, so let's see. On the top here, we have sine x over 1 plus. And then this part, we have cosine x and then square. But then cosine x is the u, so we have u square, right? U square. And then for the dx is this, du over negative sine x. And then sine x and sine x cancels each other out. That's very nice. So we can continue. Let me write it down right here. We have a negative 1 right here. So let's take it out. And this time I'm just going to write negative because negative 1 times the integral is the same as negative integral. Negative integral 1 to 0. And we have 1 over 1 plus u squared du. And now looking at this, we have to ask ourselves, the derivative of what will give us 1 over 1 plus u squared? The answer to that is inverse tangent. So this part is going to give us inverse tangent u, okay? And then don't forget we still have the negative in the front. So we have negative inverse tangent u, and then we are done with the integration part. And then, by the way, I forgot to mention this earlier. When we're dealing with definite integrals, we don't need to worry about the plus c. We can just write this down. The plus c is not needed because when you do the subtraction like this, the c will always cancel out anyways. So this is all we need. And then don't forget, the bottom number is 1, and then the top number is 0, and then we're plugging 0 first. The number on the top first, always, okay? So let's do that. The first part is going to be negative inverse tangent of 0, and then minus negative inverse tangent of 1. All right, what's the inverse tangent of 0? This is just 0, because tangent 0 is 0, so the inverse tangent of 0 is also 0. This part is gone, it's 0. That's nice. And then negative times a negative is positive. How about what's the inverse tangent of 1? This is something that you guys definitely have to know, okay? Because the original tangent of pi over 4 is 1. Therefore, the inverse tangent of 1 is pi over 4. Negative negative is positive, and this is positive pi over 4 altogether. Anyways, and this right here is the answer to this right here, okay? And you see, this is why I'd really like to show you guys 2 integrals at the same time. And I will have one more to show you guys. Okay, so let's see. Example number 3, we have the integral of x times the square root of x squared minus 1 dx. And then for the second one, we have the integral of x times the square root of x minus 1 dx. What's the difference? You see this right here, it has x squared. But then for this one here, we only have x to the first power. Which of this do you think is easier? The answer to that is the first one right here. And I wanted to tell you guys, sometimes when we're doing integrals, the more the better, and that's true in this situation. Why? Because I can just let the u equals to the inside, and the derivative of x squared minus 1 is 2x, right? And you see that x and this x will cancel each other out. That is very, very nice. And now let's put down all the work right here. Let u equals to the inside, x squared minus 1. And let's go ahead, differentiate both sides. Du will be just 2x dx. And then let's isolate the dx. Divide both sides by 2x. We get dx equals to du over 2x. And now I can take this integral into the u world. So this is going to be integral this x, and then square root. But then the inside x squared minus 1 is the u, right? So I'll put down u inside. Dx is du over 2x, so I'll put down du over 2x. And you see this x and that x cancel each other out. That's very nice. we have a 1/2 right here, so let's put down the outside of the integration. And then we're going to integrate square root of u. How can we do that? Well, let me put on the integral sign. We are going to integrate, instead of the square root of u, we'll look at this as u to the 1/2 power du. This is what we do whenever we have a square root or any kind of radical or roots, right? Write that as a power. And this is in the u world, so let's go ahead and integrate that. We can use the power rule, but do it backwards. We add 1 first. 1/2 plus 1 is 3/2. And this is the new exponent. And we have to divide it by this right here, which is the same as multiply by the reciprocal. So I'm going to put down 2/3, right? Reciprocal. And you see this 2 and that 2 will cancel each other out. Then 1/3. This is u to the 3/2 power. And then we are done with the integration step. And now we can just write this back in terms of x. So we have 1/3. I can open the parentheses for the u, which is x squared minus 1. And then all this raised to the 3/2 power. And this is legitimate. You can just put plus c and present this for the answer. But sometimes you may also like to write this in terms of the square root, because you have the half power here. The over 2 right here is the square root. So I can also write this as 1/3 on the outside, right? This is 1/3. This is on the outside, and then the half power is the square root, and then you can put down x squared minus 1. And don't forget, we still have that third power here. This is also okay, and then put plus c. Either way, which one that you prefer. So that's it for that one. And now you are wondering, okay, for this one, we have the integral of x times the square root of x minus 1 dx. This is only to the first power. Earlier, when I have x squared, I differentiate that, I get 2x. The minus 1 becomes 0, so doesn't matter. But then, this is just x. If I differentiate x, I get 1. So 1 cannot cancel with this x. Do you think this still works? So now, here is another thing we want to study. This is right here, is that sometimes when we're doing u sub, it may not work as nicely as this kind of things. We may have to do more algebra in order to make it work nicely. So, in fact, we can still use u-substitution, and I'm still going to let u equals to the inside, x minus 1, and we still follow the same procedure. Even though I cannot cancel this x right away, but this is the algebra that we can do. So let me show you. Still differentiate both sides. On the left hand side, we get du, but then the derivative x is 1, and then this is 0. So it's just pretty much 1 dx. I can just put down dx, and that's all. Du is the same as dx. Dx is just du. So we are ready. And let's take a look on how does this look like in the u world. We have the integral right here, and then x is just x, right? Because this is what we have at the moment. My focus was I will change the x minus 1 into u. So I have the square root right here, and then this was the u, and then the dx was the du. Unfortunately, this x is still here. This part, I don't have any additional x in the denominator to cancel out this x. And that's why I said sometimes the more the better, right? So what can we do? Can we integrate this already or not? No, because this right here is an x. And keep in mind, x is not invited in the u world. However, we can still continue with this because right here we have an x, and we do have a nice connection between u and x. And let me write this down again for you guys. U is equal to x minus 1. And why don't we just add 1 on both sides? Because this way we can say x is equal to u plus 1. And then instead of this x, we can just change this to u plus 1. Then everything will be in terms of u. Everybody happy, right? So now this is going to be integral x is u plus 1, and be sure to use the parentheses. So we have the parentheses u plus 1. and we still have the square root of u du. And finally, this integral is completely in the u world. And the point right here is that sometimes we may have to do some algebra to make sure things happen. Don't just give up right here. Look back to the u equation to see what we can do. Okay, how can we integrate this? Can we just use the reverse power rule with the u? No, because this u and the square root of u are affecting each other, right? So we have to make sure we multiply things out. So we're still just doing algebra right now. So let's write the u as u to the 1/2 power for the square root right here. So this is integral u plus 1, and this is u to the 1/2 power du. And take this, multiply, right? Just algebra for now. Integral u times u to the 1/2 power. This is like u to the first power, and when you multiply, we add the powers, right? So when you multiply, we get u to the 1 plus 1/2, which is 3/2. And then this times that is plus u to the 1/2 power du. So far, just algebra. And now we can finally do the reversed power rule. Integral u to the 3/2 power. What we are going to do is add 1 to the power. 3/2 plus 1 is like, say, 3/2 plus 2 over 2. 3 plus 2 is 5, so this is 5/2. And divided by 5/2, it's the same as saying multiply by 2 over 5. So the first part is going to be 2 over 5 u to the 5 over 2. And then the next part, we have u to the 1/2. Let's add 1. 1/2 plus 1 is 3/2, and then divide by 3/2 is the same as multiplying by 2/3. And this is positive, so we add 2/3 u to the 3/2 power. And this was the integration step, and we are done for that. Finally, we just have to write this back in terms of x. Well, this is going to be 2/5, and u is x minus 1, so let's put down x minus 1 raised to the 5 over 2 power, and then we add it with 2/3. This u is x minus 1 also, and then this is 3/2 power. You can present this answer, or you can write the half power as square root, just like how we did it right here. So this is going to be 2 over 5. I will write this as a square root x minus 1 in the parentheses, and then raised to the 5th power, and then plus 2/3. The half power is the square root, and then the x minus 1 raised to the 3rd power, and plus c. So either way, which one that you want to use to present your answer.